Hey everyone, welcome back to the channel. If you're new here, we break down how tech really works behind the scenes, and today we're diving into fintech. Let's be honest, fintech looks smooth from the outside, but behind that one-tap payment, there's chaos. Every swipe, every transfer, every KYC step, it's fighting its own battle. Latency, fraud detection, and stricter RBI audits than ever before. In 2025, when digital payments in India cross 480 billion transactions a year, a single backend failure can cost lakhs, or worse, lose customer trust. So today, we're going behind the curtain to see why building fintech backends is one of the toughest engineering jobs and how smart system design, from payments and UPI to KYC and compliance, keeps this invisible machinery running flawlessly. Number 1. Why fintech backends are complicated. First, let's talk about scalability. In fintech, traffic doesn't rise steadily. It spikes. Think of salary days, UPI festival sales, or a sudden wave of small payments. If your system isn't built to scale horizontally, you run into big trouble. Then there's security and compliance. And we're not just talking about encrypting data. There are PCI DSS requirements, RBI mandated audits, even GDPR-style controls for certain data. Every API call, every database write has to be tracked and validated. And third, integration overload. KYC, payment gateways, bank APIs. Back-end engineers in fintech deal with dozens of microservices. Each integration is a potential point of failure, and we need to design for resilience. Number 2, architectural mindset shift. What I've learned, and what more teams should adopt, is a microservices-first architecture. Rather than building a monolith, we break the system into smaller modules, each handling a domain like payments, risk, user profiles, and communicate over well-defined APIs. We also run API-first contracts, which means front-end and back-end teams can work in parallel without stepping on each other's toes. And finally, automated monitoring and CI/CD pipelines are non-negotiable. In fintech, we need to catch errors early and recover fast. Number 3, security by design. Security is never an afterthought in fintech. We build security by design. That means encrypting data at rest and in motion, using role-based access control and tokenization wherever possible. We also build audit-ready logs, not just for debugging, but because regulators demand them. Some of our systems, especially those dealing with KYC or high-value transactions, even run real-time anomaly detection to flag suspicious patterns before money leaves the system. Number 4, designing the right fintech backend. The first one is microservices plus API gateway equals modularity and safety. The problem? Traditional banking systems are usually monolithic. One giant app managing transactions, KYC, user profiles, notifications, etc. When one part fails, the whole thing can crash. The solution? Split the system into microservices, small, focused services for specific domains. User service handles registration, KYC data. Payment service handles money movement and settlement. Risk/fraud service checks transaction anomalies. Notification service handles SMS/email updates. All of these talk through an API gateway like Kong, Nginx, or AWS API Gateway. This gateway adds authentication, rate limiting, and logging, so if one service goes down, others stay stable. For example, When we moved our payment and KYC modules into separate microservices, it reduced deployment pain by 70%. The API gateway became our traffic hub, routing requests safely and keeping everything observable. Next is reliable data pipeline, PostgreSQL plus Kafka. The problem? Fintech transactions are real-time. A small delay can lead to double debits, missing ledgers, or reconciliation nightmares. The solution? Use a combination of PostgreSQL for ACID-compliant transactions, and then Kafka for event streaming and async processing. Here's how it works. When a user sends money, the transaction is instantly recorded in PostgreSQL that's done synchronously, so the user gets immediate confirmation. At the same time, an event called transaction initiated is sent to Kafka. From there, other services like fraud detection, notifications, and reporting pick it up and process it asynchronously. This way, the user doesn't have to wait. Everything happens in the background while they move on. For example, in our bank systems, we learned to separate real-time confirmation from back-end reconciliation. PostgreSQL ensures integrity, Kafka ensures speed. Next, security-first DevOps. Fintech backends deal with sensitive data, keys, personal information, financial amounts, but many teams still push code without proper security gates. The solution? Build security checks directly into your CI/CD pipelines. Every build should pass vulnerability scans before deployment. Use tools like SonarQube or Snike for static analysis and dependency scanning. Vault for managing API keys and secrets, and pre-commit hooks to block unsafe code before it merges. This way, you're not relying on manual reviews or last-minute audits. Security becomes part of your everyday development process. Now, every commit triggers a security scan. If a dependency has vulnerabilities, the CI stops the building automatically. That's peace of mind you can't skip in fintech. The last one is horizontal scaling and monitoring. Many fintech systems fail because they scale vertically, which is adding CPU/RAM, instead of horizontally, which is adding more instances. The solution? Design for horizontal scaling using containerization and orchestration tools like Docker and Kubernetes. Each microservice can spin up multiple pods when traffic spikes, then scale back down automatically when things settle. Add real-time monitoring with tools like Prometheus and Grafana for performance metrics and latency charts, and the ELK stack, Elasticsearch, Logstash, and Kibana for log analysis and alerting. With dashboards and alerts in place, you can spot transaction lag or queue buildup before customers even notice. During UPI festival traffic, for example, our payment pods scaled from 8 to 40 automatically, and Prometheus alerts help us catch latency spikes before users even raise the ticket. So that's a quick look at how fintech systems stay reliable behind the scenes, from scaling and monitoring to security and compliance. In short, building a fintech backend is not just coding. It's an art, blending speed, security, and regulation in one system. As backend engineers, we must think not only about what works today, but how the system will behave under pressure, under audit, and under scale. If you like this video, hit subscribe to join me on Code with Clarity. I make videos every week on backend engineering, system design, and real-world architecture. Thank you, and see you on the next one.